Okay, again, now that I've got the recording going, today we're going to go over section 5.1, or the first part of today is going to be over 5.1. And it's an introduction to polynomials, and it's really taught in a way like you've never seen a polynomial before. You'll be able to grasp the concepts and understand what's going on. We're going to start talking about, how to define a polynomial, how to find the degree of a polynomial, how to add, subtract, multiply, all that fun stuff is going to be in this section. Okay, let me get everything saved in the right spot. Okay, we're good to go. So the first thing that we've got to talk about with polynomials is how to define them, and really how your book defines them. Your book defines polynomials. I'm going to read straight from the book. It's on page 340. It says a term is a number or the product of a number and one or more variable raised to powers. The numerical coefficient, or simply the coefficient, is the numerical factor. So if we wanted to look at terms, which you really need to define before you get to polynomials. So if we look at terms, a term would be like 2x squared, or 1/2 xy cubed, or even just a number like 4 would also be a term. Now, the number in front of the variable is considered the coefficient. So your book kind of starts there with coefficients, which are going to play a big part later on in college algebra, actually. The coefficients tell us a lot about once we start graphing and making these equations. But let's define those. So the coefficient is just the number in front. So 2, 1/2, and 4. Well, it turns out a polynomial is just made up of addition or subtraction of terms, okay? But the rule is so let's define it like the book does. A polynomial is a finite sum of terms in which all variables are raised to non-integer powers, and no variables appear in any denominator. So if we look at the terms in a polynomial, the degrees, you can call this the degree, but the exponents can't be negative, and they can't be fractional, and also they can't be in the denominator. Okay, so we're going to look at examples of polynomials and not polynomials. Okay, we're going to make a bucket here: polynomials, not polynomials. Okay, so actually all three of these would be considered polynomials. But if we looked at, let's say, 2x to the 4th minus 3x squared plus 8, okay? If we looked at each one of these, you'll see that the exponent on the variable is all positive. Positive 4, positive 2. We also don't have fractional exponents. These are nice integers, right? 4, 2, actually they're nice whole numbers, 4 and 2. The constant is the same. Now I'm going to tell you, there really technically is a variable on the constant. It's just raised to the 0 power. And we talked about that last week, right? Anything raised to the 0 power is just 1. So we don't write it, but technically there is a variable attached to any constant in a polynomial. It's kind of neat. Now, not a polynomial would be something with a negative exponent. So if we looked at, like, let's say 1/2 x to the negative 3 plus 2x to the 5th. Okay, look, we have addition of terms, right? These were 3 terms. This is 2 terms. This is definitely not a polynomial. And let me pull another box of markers over the weekend. So we should have a little better marker action going on right there. Okay, that's the reason this is not a polynomial, because it's raised to the negative power. Okay, we can't have negative powers. Okay, so let's look at another one. Like the constant 5. That would be considered a polynomial. I know it's not addition or subtraction. You don't have to have addition or subtraction, but it's still considered a polynomial. Okay, well, I should start defining these. Where did your book do that? I don't remember seeing it. Oh, yeah, okay. So this guy right here is considered a trinomial because there's 3 terms. Okay, this would be considered a monomial because there's 1 term, right? Monomial. Because there's 1 term. Now let's write something that's not a polynomial here, just for an example. If we had an x in the denominator, which really is a negative x power. So if we had, like, let's say 5 over x plus 7, okay? This would not be a polynomial because the x is in the denominator, okay? So it's not a polynomial, okay? We could also have multiple variables. That's fine as well, and we're still considered a polynomial. So if we had like 2x squared y minus 3xy cubed, something like that, this would still be considered a monomial now, or polynomial. Now this would be a binomial, right? Because there's two of them. That's a binomial because there's two of them, right? Very straightforward and easy. Let's see if they throw. I'll tell you, your book doesn't do this example, but it is true. It's because it hasn't talked about fractional exponents yet. But we can't have fractional exponents be polynomials either. So we couldn't have like 2x to the 1/2 plus 3x to the -2. Now, both of this is definitely not a polynomial because we can't have a negative exponent. It's got to be a nice whole number, 2, 3. You know, there's really ones here, right? 2, 4, 0. And really a 0 here as well. It's got to be nice whole numbers. So no fractional exponents and definitely no negative exponents. So these are good examples of not polynomials, and these are good examples of polynomials. And just try means there's 3, mono means 1, and then bi means 2, okay? And I'm going to see, it doesn't really talk about, yeah, if there's more than 3, we just call it a polynomial, okay? I mean, you can say quadnomial and pentanomial if you want, that's fine. But we typically just stick to these 3. These are the 3 most common types of polynomials you'll see. And if it's greater than that, we just don't usually give it a common name, okay? Any questions about that? So we've got terms, coefficients, defining really what a polynomial is. It's just the variables have non-negative exponents and non-fractional exponents, and x's can't be in the denominator, okay? And they've got trinomials, monomials, and binomials. Hopefully this is something you've seen. I'm just kind of bringing it back from the past, okay? Bringing it back from the past. Okay, so then your book goes over the degree of a polynomial. Actually, before a degree of a polynomial, we've got to go over a degree of a term. So the degree of the term is the sum of the exponents on the variables contained in the term. So let's look at, instead of term and coefficient, let's look at term in degree, okay? So if we had, let's say, 5x squared, the degree of this single term would be 2 because it's the degree of the one variable's exponent, okay? So 5x squared, the degree would just be 2. But if we had multiple variables, let's say we had like 2xy squared, okay? Well, it's to get the degree of this term, since we have 2 separate variables being multiplied, all right, everything's being multiplied, it's a single term. If there was addition or subtraction, this wouldn't be a term, right? It would be a polynomial. So to find the degree of this, actually, we need to think of this x as being raised to the first power. And then we just add the exponents. Remember, when you multiply bases, you add the exponents. That's kind of where it's coming from, okay? So we're going to add the exponents together, 1 plus 2, and we wind up with 3, okay? If we had, let's say, a constant, like 6, we've got to remember what I told you earlier. Remember, if there's no variable, if it's a constant, the variable is actually raised to the 0 power, okay? So the degree of a constant will always be 0, okay? And notice the degree has nothing to do with the coefficient. The coefficient can be whatever it wants to be. If we just did one more, let's say we had, let's see if your book throws anything weird at you. Let's say we had like negative 5.2x squared y to the 5th z cubed, okay? So that's a squared. I know it's kind of hard to see, but it's a squared. If we had negative 5.2 x squared y to the 5th z cubed, it's okay that the coefficient's negative. That's not a big deal. But we've got 3 different variables going on, x, y, z. So we've got to add their exponents together. 2 plus 5 plus 3 winds up being 10, okay? Winds up being 10. So that's the degree of the term, okay? Now, the degree of the polynomial, though, comes from the greatest degree of any of its terms. Okay, so the degree of the polynomial, write this up here, degree of term comes from that. But then the degree of the polynomial, oh my Lord, we'll chalk that up to being a Monday. Okay, let's say now we're given polynomials and we're asked for their degrees. Okay, so if we're given polynomials and we're asked for their degrees, it's always going to be the largest of the degrees of each term. So if we looked at something kind of basic, let's say 2x plus 5x to the fourth minus 8x squared. Okay, so we've got this nice trinomial, right? 3 terms. They're all x values. That doesn't really matter too much for the degree. But if we looked at each term, so we've got 3 terms going on. If we looked at, actually, let's make these. We have 3 terms going on. Each one of these terms has a different degree, right? The term of the first, or the degree of the first term would be 1. The degree of the second term would be 4. The degree of the last term would be 2. Well, the largest degree of the polynomial terms is 4. So the polynomial's degree would be considered 4. Okay, you don't add these up or subtract, or you don't add these up like before because there's addition and subtraction. We have multiple terms. You do that for a single term. Okay, is when you add the variable's exponents to get the degree. Okay, so if we looked at another example, if we had, like, let's say 3x squared y minus 4xy plus 7. Okay, 3x squared y minus 4xy plus 7. Now, again, we've got to think of these variables by themselves. There's really just a 1 there, right? And then this constant, remember the constant degree is 0, okay? So this first term, the degree would be 3, right? The second term, the degree would be 2, because you add those together. And the last term, the degree would be 0. So therefore, the largest termed degree, okay, degree of a term is 3. It's this first one. So therefore, the degree is 3. Okay? Let's see here. Got anything else kind of goofy going on? I think that's about it. Do you guys have any questions about terms, degrees, polynomials, degrees of polynomials, definitions of polynomials? It's the first 2 pages in your text on page 340 and 341. Okay. Okay, so now we go on to really the math of polynomials, or the arithmetic of polynomials. We'll put it like that. I'm going to move this just a little bit. The arithmetic of polynomials. So first, it's really about combining like terms. Okay, we've got to be able to combine like terms. And when can we combine like terms? We have to have like terms, right? So before we get started talking about combining terms, we've got to talk about like terms. And this terminology is going to come up later. It's going to be called like radicals. We'll talk about that. And it really is very similar. So although this is a basic term or basic kind of definition and content, it builds on itself in a way because it pops up in different angles and different areas. Okay. So first off, what is a like term? Well, your book says before we add polynomials, like terms we're considered like terms if terms are considered to be like terms if they contain exactly the same variables raised to exactly the same powers. Okay, so if we looked at like terms, we'd have to have the same exact variables raised to the same exact powers. So like 5x squared y and negative 10x squared y. These would be considered like terms. They've got the same variables, x and y, and the x and y are raised to the exact same powers in each term, right? X is squared and y is raised to the first power. So these would be considered like terms. So non-like terms we use the same exact numbers here. But we're just going to switch Timbers. Oh, Lord. This feels like a Monday terms. We're going to just switch around the exponents. So if we had like 5xy squared and negative 10x squared y, okay, these would be considered non-like terms because the x's, even though we have the same variables, x and y, the exponents are different. X is raised to the first power, this x is raised to the second power, this y is raised to the second power, this y is raised to the first power. So they're not considered like terms. Okay, remember, it's got to have the same, really it's got to have the same base in a way and same exponent for each term. Let's look at a few more. Let's say ones that we'll kind of see more common to kind of see. Let's say we had 6x to the fourth negative 10x to the fourth, right? These would definitely be like terms. We got the same variable x and it's raised to the same exponent 4. Where a non-like version of this would be if we changed one of the bases. Let's say it was 6x to the fourth and negative 10y to the fourth. These would be non-like terms, right? Because we have a different variable. Same exponent, but different variable. So therefore, it's non-like terms. Okay? I hope this makes sense. So like terms, also if you use numbers like 7, any other number that doesn't include a variable, let's say like negative 20, these would be non-like terms, or these would be like terms, right? Non-like terms if you add a variable in there. So if we have like 7x and negative 20, these would be non-like terms because there's a variable for one and a constant for the other. Okay, and why do we care about like terms? Well, it turns out we can add and subtract like terms, right? If we have like terms, we just add or subtract whatever the operation tells us to do, the coefficients. So if we looked at, let's look at this first one. And let's say we were going to add them together. So this is combining like term. So if we had 5x squared y minus 10x squared y, okay? These are like terms, right? We defined that earlier. Same variables raised to the same powers. And if we have like terms, which we do, we want to keep the variables raised to those powers. Let me get another color. I bought a few different colors. There, let's go blue. If we have the same bases raised to the same powers, then all we have to do is add or subtract. For this example, would be subtract the coefficients. So we get 5 minus 10. That equals negative 5x squared y. Okay, negative 5x squared y. Very straightforward. So if we had a string of these, we could combine like terms within the overall polynomial. So let's say we had 3x squared minus 5x plus 10x squared minus, I don't know, 7x. Doesn't matter. Okay. Now we've got this polynomial here, right? Each one of these x values is raised to a nice integer, 2, 1, 2, 1. But we do have common, not common. Sometimes these are called common terms. That's why I said that. But your book calls them like terms. So we've got like terms going on. So we can add the x squareds together, and then we can really subtract the x's together. So when we add the x squareds, we got 3x squared. It's like 3 apples plus 10 apples, guys. So we get 13 apples. Okay. And then we've got negative 5 oranges minus 7 oranges. Oh, we've got negative 12 oranges. Okay. We've got to keep the variable. Okay. You have to keep the variable. Okay. Sweet. Awesome. So let's look now at really adding and subtracting these polynomials. So let's say I gave you a polynomial. This is adding and subtracting. So let's say I have 15x squared minus 10x plus 20. And I'm going to add 3x cubed minus 8x minus 19. Okay, so I've got these two polynomials. We're going to talk just a minute about them to kind of review stuff from before while you're writing it down. Okay, look, this first polynomial right here in parentheses, it's got a degree of 2. because it's the largest of the exponents. It's a trinomial, right, because there's 3 terms. The second polynomial, still a trinomial, but the degree is a little different. The degree is 3 because the largest x value is 3. Now, what's nice about adding polynomials, all you have to do is add the like terms in each parentheses. So notice there's no x squared over here, so I don't have to add an x squared. I'm going to write that here. Negative 10x minus 8x, that's going to be a minus 18x. 20 minus 19, really plus negative 19, that's going to be a plus 1. And then don't forget the 3x cubed. It didn't combine with anything in this first term, so it's just going to go right there, okay? So you can combine, like 15x squared and the 3x cubed didn't have a like term in the other polynomial, but if the like terms in each polynomial, you can combine with the arithmetic. So for this, it's addition, right? So negative 10 plus a negative 8 gives us the negative 18. 20 plus negative 19 gives us the positive 1. Now look, I don't see where your book talks about this, but it is so important for this one weird section in college algebra that I'm going to sit just for a minute and talk about it. And it's descending order, okay? It is very common, and it's really used later on for other arithmetic reasons in higher level math, like once we get to the college algebra class, to write these terms in descending order. And what descending order means is you write them in the degree order. So this 3x cubed is the degree term, so it goes first, and then the squared term goes second. The x goes next, and then the constants always last, okay? So this would be descending order. So if you hear me say those words, I don't see where your book defines it. It might in here, but this would be considered descending order. And we have to use it. We go over like dividing polynomials and call it, that's a college algebra topic. And you have to write the polynomials in descending order. So that's what that means, okay? So let's go over subtraction. So let's say we had 3x squared plus 8 minus, let's say, x squared plus 9x minus 10, okay? So 3x squared plus 8, parentheses, minus, parentheses, x squared plus 9x minus 10. Now, subtraction, you've got to be more careful, okay? You just have to be more careful. It's not like addition where, it doesn't change signs. And in the end, we're still doing the same thing, though. We're combining like terms, but we're doing the arithmetic that the little operation tells us to do. So for this one, let's look at the 3x squared. 3x squared minus, we have an x squared in the other bucket, the other polynomial. Oh, notice this is a binomial, trinomial, okay? But 3x squared minus x squared, that gives me 2x squared. I'm done there. 8 minus a negative 10. Well, 8 minus a negative 10 is 8 plus 10, so that's plus 18. The 9x did not combine with anything in this first set, so I've got to make sure it's really like saying 0 minus 9x. Okay, you can think of it like that, but you distribute the negative to the 9, and you wind up with a minus 9x. Now, again, this isn't descending order. I'm going to get in the habit of writing these in descending order because I believe your book answers them in descending order. So it's not a bad habit to get into anyway. So 2x squared minus 9x plus 18. Okay, and that is my polynomial after I combined with subtraction. So we've got addition, we've got subtraction. And again, this is in descending order, okay? In descending order. Okay? Questions about this? I'm going to look through your homework and see if I've kind of missed anything. Maybe I'll do one that's a little different. Yeah, I'll do one that's more like verbiage instead of just written out in this, arithmetic form. Let's find one of those. Hold on. Yeah, okay. This is looking at your homework, which starts on page 346, but I'm going to look on page 347. Let's do one towards the end. It says, oh yeah, this one has a fraction in it as well, our favorite, right? So this is number 44 on page 347. And it states subtract 13x squared plus x squared y minus 1/4 from 3x squared minus 4x squared y minus 1/4. Okay, so we're going to subtract this from this. So we're going to subtract this first polynomial from the second polynomial. Okay, so the way you actually write that is, since we're subtracting, this is like saying subtract 2 from 5, right? So it would be 5 minus 2. So you're going to write the second polynomial first. If we want to write it in the subtraction way of writing it, 4x squared y minus 1/4. And then we're going to subtract off 13x squared plus x squared y minus 1/4. Okay, because you're going to write the second one first because you're subtracting the first polynomial from it. Okay, now look, let's go over a little bit. These are both trinomials. The degree of these, though, is not 2. It actually comes from that second term. The degree of the second term for both of these is 3, right? You see that x squared y. So therefore, you add the exponents. This would have a degree of 3. Now this last term is 0, right? Because it's a constant. So therefore, the degree of both of these would be 3. Kind of neat. So let's get to the actual topic, though, for this question, which is subtraction. So I've got to do 3x minus 13x. So the 3x minus 13x, that's going to be, I'm sorry, squared, 3x squared. That would be minus 10x squared. Okay, and then I can combine the middle two, right? X squared y. So let's do that. X squared y. So we got negative 4x squared y minus x squared y. So that's really negative 4 plus, now really there's a 1 there, right? So negative 4 minus 1, so it's minus 5 x squared y. And then we get negative 1/4 minus a negative 1/4. Well, that's negative 1/4 plus 1/4, right? The two negatives cancel. So this winds up being 0. These two cancel out because they're opposites. Negative 1/4 minus a negative 1/4. Hey, that goes away. There's my solution. Now, this is not written in descending order, right? If I want to write this in descending order, I need to write the x squared y first. Okay, I didn't do that. That's fine. Not a big deal. Okay. Question. Now, your book goes over another way of adding and subtracting these, and it's writing it vertically. And actually, it's very nice to do it this way. If you're, I hate to say visual, there's been no proven things with visual learners and auditory learners. That's all just kind of hocus pocus. But if you like seeing things visually, this is a way of adding or subtracting in a visual manner. So let's look at another example, and I'll write this out vertically. I like calling it that way. It's writing it vertically. Let's say we had, I'm just making one up here. Let's say we had 3x squared plus 8 plus, let's say 5x squared minus x plus 10. Okay, the way you would write this vertically is, now you've got to account for every term when you do this. So you have to include what's called missing terms. So notice on this 3x squared plus 8, over here we've got an x, but here we don't. So you have to include that. So we'd actually write this first term as 3x squared plus 0x plus 8. Okay, this is called including missing terms, right? There's nothing wrong in that. And the reason we did that is because the other polynomial has an x. And then we're going to add 5x squared minus x plus 10. Okay, it's just old school addition, right? This is what we learned back in, kindergarten, first grade. But instead of it just being numbers, we're looking at variables too. And what's nice is you're going to add these guys. So we're adding these vertically. So 8 plus 10, 18. 0 plus a negative x, that's going to be negative x. Ooh, that's a negative. And then 3x squared plus 5x squared, so that's going to be 8x squared. Okay, I'm going to rewrite that one because it looks goofy. So we wind up with 8x squared minus x plus 18. Now you could have got there from the same way we did it earlier. 3x squared plus 5x squared, 8x squared. 8 plus 10, 18, and then we've got a minus x here, okay? You can get there doing it either way. Your book sets up some of the questions in a vertical format. I wanted to show you where it was coming from, though, before we looked at an example that was already in a vertical format. For example, let's look at a subtraction one that's already set in a vertical format. So let's say we have, this is number 40. Number 40 looks like this. Negative 4x cubed plus 4x squared minus 4x. And then we're going to subtract now. And they put a parentheses here, but we're going to subtract 2x cubed minus 2x squared plus 3x. And now instead of adding each one of these together, and notice we have each one has terms on top of it that are the same. You have, oh yeah, I didn't really mention that before. The terms have to line up. Remember, because if we're going to add or subtract any terms, they have to be like terms. So the like terms have to be on top of each other, okay? So we've got negative 4x cubed minus 2x cubed. That's going to give us minus 6x cubed, right? Negative 4 minus 2. 4 minus a negative 2x squared for both. So 4 minus a negative 2, that's going to turn into 4 plus 2. So 6x squared. And then negative 4 minus 3, that's going to be minus 7x. Okay? So when it's set up to subtract or add vertically, it is kind of nice. You don't have to add an extra step in there. You can just add these vertically, and there's nothing wrong in that. It's not like one's better than the other. I don't want to really make you think one way is the best way. It's more of how you like or how you visually see it, kind of thing. But it's and your book kind of throws different ways of looking at it. With the verbiage way, subtract this from that, the vertical way here, and then just the regular addition or subtraction of polynomial way that we've gone over. Okay. Okay. I'm going to stop here and ask you guys, do you have any questions about 5.1? So 5.1 was over really defining terms, defining polynomials, their degrees, like terms, and then we got into adding and subtracting like terms and adding and subtracting polynomials. A really good introduction of polynomials, okay? Really, really, really good introduction of polynomials.